When you hear the name 3I/Atlas, it doesn't sound particularly threatening. In fact, it almost sounds like a catalog entry, something tucked away in the long lists of astronomical discoveries that scientists publish every year. But behind that ordinary name lies something extraordinary, a visitor from the depths of interstellar space, a fragment of another star system, passing through our cosmic neighborhood for reasons we can barely begin to guess. And as with every unexpected traveler, there is always the unsettling question: what's the worst that can happen? 3I/Atlas is an interstellar object, only the third of its kind ever detected. The 3I, in its name literally means the third interstellar, a shorthand used by astronomers to mark how rare this class of objects really is. The first, 1I/Oumuamua, startled the world in 2017 with its strange cigar-like shape and puzzling behavior. The second, 2I/Borisov, came a couple of years later, resembling a more ordinary comet but carrying the undeniable fingerprint of alien origins. Then, quietly, came 3I/Atlas, another whisper from the void, another reminder that our solar system is not a closed bubble but a crossroad where strangers can appear at any time. The discovery itself was made possible thanks to the Asteroid Terrestrial Impact Last Alert System, ATLAS, a pair of robotic telescopes in Hawaii designed not for cosmic sightseeing, but for planetary defense. Their mission is simple but terrifying in implication: to scan the skies every night for asteroids that could hit Earth. The system has saved us more than once already by catching space rocks just hours before they brushed past our planet. But in this case, Atlas saw something not heading directly toward us, but instead tearing across the sky on a path so steep and so fast that it betrayed its origin. This was no ordinary comet bound to the sun. This was something passing through, something that had begun its journey long before humans had even learned to walk upright. To grasp why astronomers reacted with a mix of excitement and unease, we need to understand what it means for something to be interstellar. The comets and asteroids we usually study are leftovers from the birth of the solar system, chunks of ice and rock that orbit the sun in predictable paths. They may come close, they may occasionally collide, but they are, in a sense, familiar. An interstellar object, by contrast, comes from outside. It formed around another star, in another disk of dust and gas, under different conditions entirely. It is alien in the most literal sense of the word. Its chemistry, its structure, even the way it reflects sunlight may tell us about worlds we will never see. And it also means that its orbit is unbound. Once it passes through, it will never return. 3I/Atlas, therefore, is both a fleeting gift and a sobering reminder. A gift, because it offers us a once-in-a-civilization chance to study matter from another star system without leaving home. A reminder, because it shows just how porous the walls of our solar system truly are. Things can come in, things can leave. The boundary is not a fortress, it's a doorway. And doorways, of course, swing both ways. The comet's path, once reconstructed, revealed its astonishing journey. Traveling at tens of kilometers per second, 3I/Atlas entered our solar system at an angle no ordinary comet would ever take. Astronomers could trace its motion backward, plotting the trajectory like detectives retracing footprints. They found no bound orbit, no connection to the Oort cloud, no parent body within the sun's grasp. Instead, the math told a simple, chilling truth. It had come from the stars. It was here briefly, and then it was gone. If you blink, you miss it. If you hesitate, you lose it forever. And this brings us to the haunting thought that lingers every time one of these objects appears. Astronomers can assure us that 3I/Atlas is not on a collision course with Earth. Its orbit takes it past safely, a cosmic flyby rather than a death sentence. But the fact that Atlas itself, a telescope built to warn us of sudden impacts, was the one to catch it, sharpens the edge of fear. What if it hadn't just been passing by? What if the third interstellar visitor had drawn a bead straight on us? By the time we spotted it, would we even have had a chance to act? The uncomfortable truth is probably not. 3I/Atlas was faint, difficult to track, already moving fast by the time it was detected. A slightly different angle of approach, a trajectory shifted by just a few degrees, and it could have been something else entirely, A doomsday comet no one saw coming until it was too late. This is the shadow that hangs behind the science. For every harmless interstellar visitor, there could be one aimed like a bullet, crossing the unimaginable distances of interstellar space only to end its journey in fire against our fragile world. The moment astronomers realized 3I/Atlas was interstellar, the race began. Telescopes across the globe, from amateur backyard setups to giant observatories perched on mountaintops, scrambled to catch a glimpse. Unlike planets and asteroids that dutifully retrace their orbits, interstellar visitors are one-time shows. You see them once, and then you never will again. That urgency drives the scientific community into a frenzy. Every second counts, every photon of light gathered matters. But there is something deeply unsettling about the process itself. When you hear that humanity has detected an interstellar comet, it's tempting to imagine we caught it early, tracked it from the edges of the solar system, and calmly studied it as it approached. The truth is less reassuring. Objects like 3I/Atlas are not detected years in advance. They appear suddenly, often already well within the solar system, only noticed because their motion looks wrong compared to local comets. By the time we know what they are already moving away, already fading into the background of stars. We don't really catch them. We glimpse them and then they vanish. Consider how this compares to Oumuamua, the first interstellar object. When it was first spotted, astronomers thought it was an ordinary asteroid. Only after painstaking analysis of its orbit did they realize it was something far stranger, an interstellar traveler. But by then, it was already leaving, receding into the night sky too quickly for close study. We were left with more questions than answers. Was it a rock? Was it a comet missing its tail? Was it something even stranger, perhaps an artifact of alien engineering? The debate still smolders to this day. Then came 2I/Borisov, which looked more like the comets we already knew. It had a coma, a tail, the typical behavior of an icy body shedding material as it approached the sun. But its chemistry carried fingerprints of a different nursery, a birthplace around another star. Its isotopic ratios and outgassing patterns hinted at conditions not quite like those of our own solar system. Studying it was like tasting water from another river, knowing it flowed from mountains you will never see. 3I/Atlas fell somewhere in between these two. Faint, elusive, harder to pin down. Its path screamed interstellar, but its details were harder to grasp. Was it a fragment of a larger body? A survivor of gravitational chaos flung out of its home system billions of years ago? Or was it one of countless unremarkable comets wandering the galactic deep, indistinguishable from our own except for its passport? Astronomers strained for answers, but time was not on their side. And here is where the unease sharpens. Every discovery like this underlines how thin our margin of knowledge really is. The telescopes we rely on, powerful as they are, do not give us omniscience. They give us warnings, sometimes late warnings, sometimes too late. 3I/Atlas was not dangerous, but it easily could have been, had its trajectory bent just slightly differently. Humanity likes to think of itself as a species in control, one that charts the heavens with precision. But the reality is humbler. We live on a small rock, with only a handful of watchtowers scanning the void, and the void is vast. The Atlas system, which caught this interstellar visitor, is a perfect example of both our brilliance and our fragility. On one hand, it is a technological marvel, able to scan the entire visible sky multiple times each night, detecting faint moving objects against the static background of stars. On the other, it is just two telescopes on a volcanic island chain in the Pacific Ocean. If they go offline, if the weather is poor, if funding runs dry, our planetary defense net thins to almost nothing. How many interstellar objects have already passed us by unnoticed? How many bullets have we dodged simply because chance favored us this time? The haunting part is that statistically, one day, chance will not. The Earth has been struck before. The scars are everywhere, craters dotting the moon's face, the Chicxulub impact that ended the reign of the dinosaurs, Tunguska flattening Siberian forests in 1908. Those were local events in cosmic time, mere blinks of an eye. The idea that an interstellar comet could arrive, unnoticed until the last moment, and deliver devastation on a scale we can scarcely imagine, is not fiction. It is possibility. Scientists are quick to reassure us that the odds are vanishingly small. Space is big, they say. The trajectories that would line up perfectly for a collision are rare. That is true, but it's also cold comfort. When an outcome is absolute destruction, even rare probabilities cast long shadows. It doesn't matter that the dice are weighted against disaster when the dice are rolled over and over across millions of years. Eventually, the wrong number comes up. What would it look like if 3I/Atlas had been aimed at us? First, the warning would likely come too late. A faint blur detected, a trajectory calculated, the realization spreading across observatories like a chill. Impact is certain, and the countdown is short. Days, perhaps weeks. Certainly not years. The options on the table would be grim. Could we deflect it? Unlikely. Could we destroy it? No. Blasting a comet into fragments may only turn one bullet into a shotgun blast. Could we evacuate? Impossible. The Earth itself is the target, and there is nowhere else to go. The worst-case scenario plays out in silence. The object enters the atmosphere with a light brighter than the sun, compressing air into fire, the sky ripping open with shockwaves. If it's small, maybe it burns up, a spectacular but harmless show. But if it is large, kilometers across, then there is no defense. Impact would vaporize oceans, darken skies with dust, collapse agriculture, and choke ecosystems in a planetary winter. Civilization would stagger, perhaps never recover. All from a rock or an ice ball that we only noticed after it was already here. And that is why interstellar visitors like 3I/Atlas are double-edged. They are marvels to study, scientific treasures beyond price. But they are also reminders that space is not empty, and that our place within it is far from secure. We are not lords of the solar system. We are tenants, vulnerable to eviction notices written in stone and ice. Even now, after 3I/Atlas has come and gone, astronomers replay the data, refining its orbit, squeezing every last drop of information out of the faint specks of light captured in 2022. They measure its brightness, its fading coma, its eccentricity. They run simulations backward, trying to guess which star system it might have come from. Some possibilities emerge, but none are certain. Maybe it drifted from the Orion Arm. Maybe it was cast out during the birth of some distant sun. Or maybe it has been wandering between stars for billions of years, a relic of a world long destroyed. The truth is that we will never know. And perhaps that is the most unsettling part of all, that the visitor came, brushed our doorstep, and left again, carrying its secrets back into the void. Meanwhile, we look up and we wait. There will be a 4I, a 5I, more visitors in the centuries to come. Each time, the same ritual will unfold: discovery, excitement, questions, and that quiet, unspoken fear. What if this is the one that doesn't just pass us by? When astronomers pointed their instruments toward 3I/Atlas, they were not only interested in where it was going, but in what it was. Every interstellar visitor carries with it the possibility of revolutionizing our understanding of planetary systems. The dust it sheds, the gases it releases, even the way it reflects sunlight, all of these are clues to a life history written far from here. From the limited data we gathered, 3I/Atlas behaved more like a comet than an asteroid. Its brightness curve suggested a body of ice and dust, sublimating as it approached the warmth of our sun. But it was faint, far fainter than Borisov had been. Some scientists speculated that it might not be intact, that perhaps what we saw was a fragment of a larger comet that had broken apart before entering our system. If that were true, then 3I/Atlas was not a single messenger, but the survivor of a shattering we never witnessed, its siblings lost in the dark. Comets are often described as dirty snowballs, mixtures of frozen water, carbon dioxide, ammonia, and dust, leftovers from the birth of stars. Interstellar comets, however, may carry combinations we have never seen. Borisov, for instance, had unusual ratios of carbon monoxide, hinting that it formed in a far colder environment than anything in our solar system. With 3I/Atlas, the data were thinner, but even so, its chemistry seemed odd. Some researchers proposed that it was unusually depleted, that its long exile between the stars had stripped away its more volatile components, leaving behind a ghost of what it once was. Others suggested the opposite, that what we were seeing was an object fundamentally different from our own comets, evidence of the diversity of planetary nurseries scattered through the galaxy. But here is where the what-if begins to creep back in. What if the materials it carried were not merely different, but dangerous? Comets from our own Oort cloud can contain cyanide compounds, toxic even in small amounts. Interstellar comets could, in theory, bring chemistries alien to life as we know it. Imagine, for a moment, a fragment of such a comet surviving impact with Earth, seeding the surface not with familiar carbon molecules but with something corrosive, radioactive, or biologically disruptive. The chance is low, vanishingly low, but it cannot be dismissed entirely. The history of life on Earth is tangled with the cosmos. Some theories even suggest that the first building blocks of biology came from comets. If so, then every interstellar visitor carries within it the potential to create or to unmake. Scientists, of course, treat such possibilities cautiously. They are not in the business of raising alarms. They prefer the measured language of probabilities and uncertainties. Yet even among the cautious, there is a recognition that the unknown always has teeth. When you hold in your data a thing that has traveled for millions, perhaps billions of years across the galaxy, you are holding a mystery whose full dimensions you cannot see. Another unsettling reality is how little we could actually do to probe 3I/Atlas in detail. For all our advances, humanity remains bound to Earth and its immediate orbit. We can send probes to nearby planets, to asteroids, to comets that we know about decades in advance. But an interstellar visitor gives us no such luxury. By the time we spot it, it is already passing through, already racing away. To launch a spacecraft to intercept it would take years of preparation, and we rarely have more than months of warning. With Borisov, scientists dreamed of redirecting existing spacecraft to catch a glimpse, but nothing materialized. With 3I/Atlas, the idea was not even practical. We watched from afar, powerless to chase. This inability gnaws at the imagination. Think of what it means: pieces of other star systems, carrying secrets older than humanity itself, slip past us like ghosts in the night. We see them only dimly from a distance, through glass and mirrors. We measure their light, plot their paths, and then they are gone. It is like hearing footsteps outside your window and never knowing who passed by. Were they harmless? Were they dangerous? Were they even real? And then the darker thought follows. What if one day a visitor comes not just as a ghost, but as a hammer? A body of unfamiliar composition, dense and hard, striking Earth with an energy no one could have anticipated. We comfort ourselves by saying the odds are low, that space is mostly empty, that interstellar objects are rare. But rare is not the same as impossible. In the depths of time, in the endless rolls of the cosmic dice, every outcome eventually appears. Even the mundane possibilities are not entirely without danger. Suppose, for instance, that a fragment of an interstellar comet entered Earth's atmosphere and survived long enough to strike the ground. What would its composition do to our biosphere? Would it introduce minerals or compounds unknown to us, interacting with our soil, our oceans, our lungs? Would it smolder with isotopes long decayed in our own system, but still active in the alien chemistry from which it came? Science fiction has long imagined deadly alien plagues riding in on comets. Reality is almost certainly less dramatic, but almost certainly is not certainty. The story of 3I/Atlas, therefore, is not just a story of what we know, but of what we cannot know. Its faintness limited our instruments. Its speed limited our time. By the time we had gathered enough observations to be confident of its interstellar nature, it was already receding, already too dim for most telescopes to track. It came, it whispered its existence, and then it was gone. And in that brevity lies the unease, the sense that the universe is speaking, but we cannot catch the words. Perhaps the most haunting element of all is scale. Imagine the galaxy as a sea with countless waves of stars and dust and planets. In that sea drift fragments like 3I/Atlas, scattered debris from countless shipwrecks of creation. Most will never come near us, but some will. And when they do, we are reminded that we are not separate from that sea. We are floating in it, exposed to whatever drifts our way. The worst that can happen is not just impact or destruction. The worst is the reminder of how fragile we truly are, that our sky is not a shield but an open window, and that visitors, both benign and catastrophic, can appear at any time. For now, 3I/Atlas is gone, a dim star fading in old telescope logs. But the questions it raised remain. How many more are out there? How many have passed unseen? And when the next one comes, will it bring wonder or warning? Every time an interstellar object brushes our skies, it raises a memory older than humanity itself. The Earth bears scars, written in stone and sea, of encounters with spaceborne intruders. We tend to think of the heavens as distant and serene, but the truth is far harsher. Our planet has been struck again and again, and the only reason we are here to talk about it is that none of those blows have come in living memory with civilization fully exposed. To understand why astronomers worry about visitors like 3I/Atlas, you have to remember what the past has already delivered. 66 million years ago, the age of dinosaurs ended in an instant. A rock about 10 kilometers wide slammed into what is now the Yucatan Peninsula, leaving behind the Chicxulub crater. The impact unleashed energy equivalent to billions of nuclear bombs, igniting forests across continents, boiling seas into vapor, and throwing enough dust into the atmosphere to block the sun for years. Plants died, animals starved, ecosystems collapsed. 70% of species vanished. It was not a slow decline. It was a curtain drop, a moment when life was forced to restart under new rules. Humanity owes its very existence to that catastrophe, because without it, mammals might never have inherited the Earth. But the cost of that inheritance is a permanent reminder: the sky can kill. Fast forward to 1908, over the remote Siberian taiga. A fireball streaked across the dawn sky before exploding in the atmosphere. The blast, known as the Tunguska event, flattened 80 million trees across an area the size of a major city. Witnesses hundreds of kilometers away were thrown from their feet. 4 days afterward, skies across Europe and Asia glowed with strange light. Scientists believe the culprit was a small comet or asteroid, only about 50 meters across. 50 meters, the size of an office building, was enough to devastate an area that, had it been over London or New York, would have killed millions. Tunguska was a warning shot, a reminder that not all impacts come from giants. Even the small ones can destroy. In 2013, another fragment reminded us. Over Chelyabinsk, Russia, a meteor about 20 meters across entered the atmosphere at over 60,000 kilometers per hour. It exploded high above the city, releasing energy 30 times greater than the Hiroshima bomb. Windows shattered, buildings collapsed, over 1,000 people were injured. No one died, but the event underscored a chilling fact: we had no warning. The meteor approached from the direction of the sun, invisible to our telescopes, and only revealed itself when it burned through the morning sky. If it had been larger, Chelyabinsk might have been erased in seconds. Now, imagine something like 3I/Atlas, but aimed directly at us. Interstellar comets are not necessarily larger than our local ones, but their speed is often much higher. Bound comets from our Oort cloud fall toward the sun at tens of kilometers per second, but interstellar visitors may approach at twice that speed, even more. Kinetic energy scales with the square of velocity. That means that even a modest interstellar body, if it struck Earth, could deliver devastation far beyond what its size would suggest. A fragment 50 meters wide, moving twice as fast as a typical asteroid, would release energy closer to 100 megatons, enough to level a metropolis and scar a nation. A kilometer-wide interstellar comet? That would be an extinction-level event, a Chicxulub for the modern world. Astronomers assure us that 3I/Atlas posed no such danger. Its trajectory carried it safely past, on a fleeting journey that barely intersected our neighborhood. But the thought lingers: What if we hadn't been so lucky? What if it had come from a slightly different angle, unseen until it was too late? The comfort of probability falters in the face of history. Chicxulub was improbable, and yet it happened. Tunguska was improbable, and yet it happened. Chelyabinsk was improbable, and yet it happened. To live on Earth is to live in a shooting gallery, where the targets are random and the shooters are blind. Detection systems like Atlas, Pan-STARRS, and others are our eyes in this darkness. They scan the heavens tirelessly, flagging moving dots against starfields, calculating orbits, predicting encounters. But their reach is limited. Small objects can slip through, as Chelyabinsk proved. Fast objects can be recognized too late, as 3I/Atlas reminded us. And the worst part is that funding, politics, and priorities shape how much of the sky we even watch. If a war, an economic crash, or a shift in government budgets dims those watchtowers, our fragile sense of security thins even further. The universe does not pause its dice rolls when we look away. Psychologically, humans are poorly equipped to live with such risks. We dismiss them because they are rare on the scale of a human lifetime. We focus on the threats we can see: storms, wars, diseases. The cosmos feels too distant, too abstract, and so we downplay it. But the Earth does not measure time in decades. It measures in eons, and across eons, the improbable becomes inevitable. That is the real lesson of interstellar objects. They force us to remember that the clock is still ticking, even if we pretend otherwise. What makes interstellar visitors especially unnerving is the unknown. Local comets and asteroids, at least, are familiar enemies. We have cataloged thousands of them, mapped their families, predicted their orbits. But an object like 3I/Atlas comes from nowhere, bearing no record, no predictability. It is a stranger knocking on the door at midnight. You don't know who they are, you don't know what they want, and by the time you realize they are there, they may already be gone, or already inside. And that leads to another chilling reality: near misses. How many times has an interstellar visitor passed through our solar system unnoticed? Oumuamua, Borisov, and Atlas are only the first we've seen. Statistically, there must have been countless others. Most would have slipped by without incident. But what if one had brushed closer, perhaps passing between Earth and the Moon, or even closer still? The margin between harmless flyby and disaster is razor thin. And because of the speed of these objects, the difference between we watch and wonder and we die in fire is measured not in years, but in weeks or even days. For now, we comfort ourselves with the thought that science is watching, that telescopes scan the skies, that clever algorithms will sound the alarm. And in truth, we are better prepared now than at any point in history. But preparation is not immunity. If an interstellar object of sufficient size set its course for Earth today, we would almost certainly be helpless. Our rockets are not ready, our defenses are untested, our unity as a species is fragile. We would face the end not with defiance, but with disbelief. That is why, in every calm scientific paper about 3I/Atlas, in every careful press release and every tidy diagram of its orbit, there is a shadow. Astronomers don't say it directly, because science does not deal in fear. But the implication is always there. These objects exist. They come from beyond. They pass near us. And one day, one of them may not pass by at all. When 3I/Atlas slipped through the solar system, it was easy to see it as a rare anomaly, a statistical fluke. But that perception is more about us than about reality. We only noticed it because our instruments have finally become sharp enough to catch such things. For most of human history, interstellar visitors have almost certainly come and gone, unseen. The truth is that 3I/Atlas was not rare. What was rare was our ability to detect it. Astronomers estimate that for every interstellar object we detect, thousands more pass by unnoticed. They are too faint, too small, too fast for our current systems to track. Think of the night sky as an ocean. We sit on the shore, watching with binoculars, and every once in a while, we glimpse a strange piece of driftwood float past. But out in the deep water, beyond our sight, entire fleets of debris are moving, currents carrying fragments of other star systems across gulfs of light years. 3I/Atlas is not a single messenger. It is one of countless travelers. The fact that we have seen 3 in just a few years suggests that the galaxy is far more crowded with such wanderers than we ever guessed. And if that is true, then the implications are sobering. Each interstellar visitor is a reminder that planetary systems are not permanent. They shed pieces of themselves. Planets collide, stars tug comets into exile, gravitational slingshots cast debris into the void. What drifts past our sun are the wreckage and refugees of alien histories. 3I/Atlas may have once orbited a star long gone, a system that collapsed or was disrupted billions of years ago. It may be the last fragment of a world destroyed before our Earth was even born. To study it is to peer into tragedies and origins that have no names. But there is also the faint, persistent whisper of another possibility. What if some of these objects are not natural at all? Oumuamua, the first interstellar visitor, sparked this speculation most fiercely. Its shape, its acceleration, its lack of cometary activity, all seemed odd. Some scientists wondered aloud whether it could be a fragment of alien technology, a derelict probe, or even a sail pushed by starlight. Mainstream consensus leaned toward natural explanations, but the idea never fully died. With each interstellar object we see, the question rises again. Are we sure these are just rocks and ice? Could some of them be artifacts, lost tools drifting between stars, the cosmic litter of civilizations we have never met? 3I/Atlas, faint and fragmentary, gave no reason to suspect such origins. It looked like a comet, behaved like a comet, and was treated like a comet. But the fact that we even ask the question tells us something important. These interstellar visitors represent not just physical risks, but psychological ones. They confront us with the possibility that we are not alone, and with the equally chilling possibility that we are. If they are natural, they remind us that planetary systems like ours are fragile, easily shattered, constantly bleeding fragments into the galaxy. If they are artificial, they suggest that someone else was here first, and that their reach extends far enough to brush past our home without even noticing us. Either way, the lesson is the same. We are small. The galaxy, after all, is not empty. The Milky Way is home to hundreds of billions of stars, each with its own disk of planets, asteroids, comets. Multiply that by the billions of galaxies beyond, and the number of fragments set adrift becomes staggering. Trillions upon trillions of silent travelers, each on its own lonely path, crossing the interstellar dark. Occasionally, 2 paths intersect, and a comet from another sun blazes briefly in ours. Most of the time, we never see it. Sometimes we do. And once in a while, it might come close enough to remind us how vulnerable we are. This is the paradox of interstellar objects. They inspire both wonder and dread. To the scientist, they are precious samples, cosmic time capsules carrying information from places we cannot reach. To the dreamer, they are symbols of connection, proof that the galaxy is a single ecosystem, its parts trading material across impossible distances. But to the realist, they are also warnings. Each one could be a bullet. Each one could be the herald of catastrophe. The worst that can happen is not just hypothetical. It has happened before with local comets and asteroids. Interstellar ones are rarer, faster, and harder to see coming. Our blindness is what makes the threat so chilling. For every Oumuamua, Borisov, or Atlas, how many passed unnoticed? How many near misses occurred before telescopes existed to record them? Perhaps in the year 812, a comet from another system flew between Earth and Mars, unseen by the people who tilled their fields under a quiet sky. Perhaps in 1346, while plague ravaged Europe, an interstellar fragment skimmed past Earth, invisible in the glare of the sun, carrying with it secrets no one would ever know. Even today, with our technology, the sky remains mostly unguarded. Vast sectors go unscanned, especially near the sun, where dangerous objects can hide. The cosmos does not need to aim to destroy us. We only need to fail to look. The scariest thought is not that one day an interstellar comet might hit us. It is that one day one might almost hit us, and we would never know. A near miss of a few 100,000 kilometers is still a near miss. A few thousand kilometers, and it could shear through satellites, disrupt global communications, scatter debris across orbit. Even closer, and the atmosphere itself would light up in fire. We might mistake it for a nuclear strike, panic before we understood, and plunge into chaos. The visitor does not even need to impact us to hurt us. Sometimes fear is enough. This is why astronomers chase every faint speck, why they huddle in observatories night after night, charting dots against darkness. Because each dot might be a messenger from another sun, or a bullet with our name on it. 3I/Atlas was harmless. But it could have been otherwise. And if the dice roll long enough, someday, it will be otherwise. Still, there is another layer to this story, one less terrifying but no less profound. Each interstellar object tells us that we are part of a galactic web. Material is not trapped forever in its birthplace. Worlds bleed into one another. Star systems share their fragments. Perhaps this is how life itself spread, comets carrying seeds of chemistry across the stars, scattering them like pollen, waiting for one world in 1,000 to bloom. If so, then interstellar visitors are not just threats, but also ancestors. They are the reason we are here to fear them at all. Yet, even with that poetic thought, the edge of danger remains. To live in this galaxy is to live with uncertainty. The worst that can happen is always in play, always lurking behind the calm surface of a night sky filled with stars. The stars look serene, eternal, comforting. But in truth, they are factories of chaos, spitting fragments into the dark. Some fragments pass harmlessly by. Others, someday may not. So we return to the name, 3I/Atlas. Atlas, for the system that caught it, 3I, for the third interstellar. But the myth of Atlas is also fitting. In Greek legend, Atlas was condemned to hold up the sky. Humanity, in a way, shares that burden. We hold up the sky with our watchfulness, with our fragile telescopes, with our fragile science. We bear the weight of knowing that the heavens are not safe, that the worst can happen, and that one day it might. If you stand beneath a clear night sky, far from the noise of cities, you might feel a sense of safety. The stars are distant, unmoving to the naked eye, silent in their watch. It feels eternal, unchanging. But this is an illusion born of distance and ignorance. The reality is far less soothing. The sky is not still. It is a shooting gallery, a place where rocks, ice, and fragments of alien systems hurtle in silence at speeds beyond comprehension. To live on Earth is to gamble, and every day we win only because chance allows it. 3I/Atlas reminds us of that gamble. Harmless though it was, its very existence reveals that objects from other stars are not rare myths. They are real and they come here. 3 interstellar visitors have been confirmed in only a few short years. That is not an anomaly, it is a pattern. They were here before and they will come again. The question is not if, but when one of them draws too close. Humanity likes to believe it has defenses. We speak of planetary defense initiatives, of telescopes scanning the skies, of space agencies plotting missions to test deflection techniques. And some of this is true. NASA's DART mission in 2022 proved that we could, in principle, nudge a small asteroid from its course. That was a triumph, but a fragile one. DART took years of planning, targeted a known asteroid, and succeeded only because the conditions were perfect. If 3I/Atlas had been on a collision course, we would not have had years. We would have had weeks, maybe less. No spacecraft could have been prepared, no rocket launched in time. The most we could have done is watch. And the harsh truth is that funding for such defenses is meager. Billions flow into weapons, into wars, into endless consumption. But to guard the Earth against the one threat that could erase every nation in a single stroke? Only scraps are given. The telescopes are too few, their fields of view too narrow, their coverage incomplete. Atlas itself, the very system that spotted 3I/Atlas, is only 2 telescopes on remote Hawaiian Islands. 2 pairs of robotic eyes, straining to watch a sky larger than imagination. If they blink, if the weather turns, if funding falters, we are blind again. This blindness is not theoretical. In 2013, The Chelyabinsk meteor approached from the direction of the sun. Telescopes could not see it. The explosion caught us off guard, injuring over 1,000 people. That was a 20-meter rock. What if it had been 200 meters? What if it had been 2 kilometers? Detection is not guaranteed. Protection is not guaranteed. The comforting thought that someone must be watching is only half true. Yes, someone is watching. But the cosmos is too vast for the watching to be enough. This is the cosmic lottery we live in. Every orbit of Earth around the sun is a ticket purchased. Every passing year is a roll of the dice. The odds of catastrophe in a single year may be tiny, but over millions of years, the odds approach certainty. The Chicxulub impact proved it. Tunguska proved it. Chelyabinsk proved it. What 3i/Atlas adds is the reminder that the dice are not only rolled by local players. Sometimes the throw comes from across the galaxy. Sometimes the dice are heavier, faster, and stranger than anything we expect. And what if we lose? What if, tomorrow, an interstellar comet is detected on a direct course with Earth, impact in 30 days? The scenario has been modeled. Panic would spread within hours. Markets would collapse. Governments would argue about survival plans, about hiding the truth or sharing it. Some would turn to faith, others to denial. Science would work frantically, but without time, without preparation, there would be no solution. The comet would come, unstoppable. The sky would burn, the seas would boil, and humanity would be reduced to a few survivors in bunkers, if even that. Civilization would end, not in centuries of decline, but in weeks of chaos. It is almost unbearable to dwell on, which is why most people don't. It is easier to live as if the stars are fixed, as if the sky is safe. We prefer the illusion of permanence. But illusions are fragile. And each time a new interstellar visitor is discovered, that fragility is exposed. We are reminded that the universe does not care about our illusions. It rolls its dice whether we look or not. The silence of space makes this even more haunting. Between the stars lies a void so deep, so empty, that even light takes years to cross it. In that silence, objects like 3i/Atlas drift. No sound, no warning, no intention. Just fragments of ancient systems moving through the dark. When one crosses our path, it does not announce itself with a roar. It arrives quietly, a faint blur in the telescope, a data point on a chart. And just as quietly it may pass, or it may end us. The worst that can happen is not fiery chaos, not panic in the streets. The worst is the calm before, the silence in which we realize too late that the dice have already been cast. And yet, in that silence, there is also perspective. 3i/Atlas was not our doom. It was a reminder. It told us, wordlessly, that we are part of something vast. That stars are not isolated, that worlds shed pieces of themselves, that the galaxy is a place of endless exchange. It showed us that danger and wonder are the same coin, flipped endlessly in the void. Without comets, life may never have begun here. Without impacts, evolution may never have taken its turns. We are here because the cosmos is violent. But we remain here only because, so far, the violence has spared us. It is tempting to ask whether we will ever be ready. Could we one day build a true planetary defense, fleets of spacecraft ready to intercept anything that threatens us? Could we seed the skies with sensors so complete that no interstellar object could slip by unseen? In theory. In practice, perhaps not. Such projects require unity, foresight, and the willingness to spend resources on a threat that may not materialize for centuries. Humanity has not shown much of these qualities. We fight over land, over ideology, over wealth, while the true danger drifts above us, indifferent to our divisions. So perhaps the most sobering truth of 3i/Atlas is not what it was, but what it revealed about us. The comet came, passed, and left. We studied it briefly, published papers, moved on. But the deeper lesson, that we are fragile, unprepared, and reliant on luck, is harder to face. We bury it under statistics, under reassurances that the odds are low. But the odds only matter until they don't. The dinosaurs did not care about odds. Neither will we if the dice fall badly. The name, again, feels almost symbolic. Atlas, the system that found it, named after the titan who held up the sky. In myth, Atlas was punished, condemned to bear the heavens for eternity. Humanity now shares that burden. We do not hold up the sky, but we watch it. We scan it, measure it, try to tame its randomness with equations. But like Atlas, the task is endless. The sky will always press down, heavy with potential disaster. And unlike Atlas, we have no guarantee of enduring forever. In the end, 3I/Atlas was only a visitor. It came, it showed itself, it left. No harm done, no impact felt. But its shadow lingers. Each time we look up at the stars, calm in their glittering stillness, we might remember that they are not guardians but factories of chaos, forever spitting debris into the dark. Some of that debris will find us. The worst that can happen is not an exaggeration. It is history waiting to repeat itself. Until then, we live as we always have, beneath a fragile sky, in a fragile world, carried through a dangerous galaxy on nothing more than luck and hope. And as long as we are here, as long as we tell stories of comets and stars, we must remember that the silence of space is not safety. It is only the pause before the dice roll again. The most unsettling lesson of 3I/Atlas is not about astronomy, not about chemistry, not even about orbital dynamics. It is about indifference. The universe does not care. The stars do not weigh our survival in their light. The comets do not choose their targets. The galaxy does not notice that we are here. And yet, in our hearts, we cling to the idea that the cosmos must somehow be aligned with us, that it must care whether we endure or vanish. Every time an interstellar visitor passes harmlessly by, we take it as reassurance. But it is not. It is only luck. This indifference is difficult for us to bear. As a species, we tell stories of purpose, of destiny, of fate. We want the sky to mean something, to hold messages or intentions. But comets are not omens. They are rocks and ice, indifferent to whether we fear them, worship them, or ignore them. Oumuamua did not arrive to send us a sign. Borisov did not arrive to reassure us. Atlas did not arrive to warn us. They simply drifted across our field of vision, pieces of other worlds that noticed nothing as they passed. The only meaning they have is the meaning we project onto them. And yet, that projection reveals something profound about us. When we see an interstellar object, we see both life and death. On one hand, comets may have seeded Earth with water, with amino acids, with the raw materials that allowed life to spark. Without them, perhaps Earth would have remained barren, a blue desert circling the sun. On the other hand, comets have ended ages, toppled ecosystems, rewritten the script of evolution with violence. The same kind of body that may have given us life also nearly erased it. This duality is inescapable. The comet is both parent and executioner. 3I/Atlas, like its predecessors, carried that paradox. To study it was to wonder, what chemistry did it hold? Could its ices have carried the same seeds that birthed us? Could fragments like it have fallen on alien worlds, awakening life elsewhere in the galaxy? And at the same time to ask, what if it had struck us? What if its mass, multiplied by its velocity, had slammed into Earth with unimaginable force? Would we still be here to wonder about it at all? The line between creation and annihilation is razor thin, and it drifts silently across the galaxy on paths we cannot control. This paradox grows darker when we consider scale. Life on Earth is fragile not only in its biology, but in its memory. If an interstellar comet ended us, it would not simply end our species. It would erase our story. The pyramids, the libraries, the digital archives, the monuments to our existence, all of it would be dust in time. Perhaps another species would rise, millions of years later, to find faint traces of us. But perhaps not. Perhaps nothing would remain. The worst that can happen is not simply that we die, but that we are forgotten. Philosophers have long asked whether the universe has meaning without us to perceive it. The comets answer with silence. 3I/Atlas came from somewhere we will never see, carrying secrets we will never know. It passed us briefly, then continued on, indifferent to whether we noticed. If we had not built telescopes, if we had not been watching, it would have been as if it never existed. And if we vanish, the universe will go on just as before, untroubled by our absence. That is the harshest truth of all. We matter to ourselves, but perhaps not to the cosmos. Yet, in this silence, there is also a strange kind of beauty. To know that the universe is indifferent is also to know that we are free to make our own meaning. 3i/Atlas does not care whether it frightens us, but we can choose to learn from it. We can choose to see it as a reminder of our fragility and to build defenses. We can choose to see it as evidence of life's interconnectedness, scattered across the stars. We can choose to see it as both a warning and a gift. The universe may not care, but we can. Still, denial is easier. Most people never heard of 3i/Atlas. They never looked up, never felt the chill of knowing that an interstellar stranger had passed within reach. Life went on. Cities hummed, screens glowed, wars raged, children played. The comet did not matter because it did not kill us. But this denial is dangerous. For every harmless visitor, there is always the possibility of a fatal one. And if we deny the risk until it arrives, we will be too late. Imagine, for a moment, the symmetry of it all. Billions of years ago, interstellar fragments may have seeded Earth, carrying carbon compounds, perhaps even the precursors of RNA. Life bloomed, evolved, became conscious, built civilizations. We looked up at the stars, dreamed of the cosmos, wondered about our origins. And then, billions of years later, another interstellar fragment arrives. But this one does not seed life. It ends it. The same process that began us also erases us. Creation and destruction, two sides of the same coin, flipped endlessly in the dark. That is the essence of cosmic dread. Not that the universe is hostile, but that it is indifferent. Not that the comets want to kill us, but that they might, and they will not even notice. Our survival is not guaranteed, not protected, not fated. It is only a matter of roles in a game we do not control. And one day, the dice will fall against us. What, then, is the worst that can happen? It is not just extinction. It is irrelevance. It is silence. It is that 3i/Atlas passed us by, unknowing, and the next one may not. And if that one erases us, the universe will not mark the loss. The stars will shine as before. Other comets will drift as before. The galaxy will not notice that the Earth was once blue, once alive, once filled with voices that told stories under the stars. And perhaps, in that realization, lies the true weight of Atlas. The Titan in myth bore the heavens on his shoulders, punished to carry what he could not change. Humanity, too, bears that weight. We cannot change the indifference of the cosmos. But we can see it, name it, and tell the story. 3i/Atlas was only a whisper, but it was enough to remind us. The sky is not safe. The worst can happen. And when it does, the only question will be whether we faced it with denial or with awareness. Until then, we look up. We build telescopes. We measure faint specks of light. We hold the silence of the universe on our shoulders, knowing it does not care whether we endure, but caring anyway. That is our defiance. That is our meaning. And that is what 3i/Atlas left us. The knowledge that we are fragile, temporary, and small, but alive, for now, beneath a sky that may yet fall. The story of 3i/Atlas is not finished, even though the comet itself has long since passed beyond our reach. Its light faded from our telescopes, its path carried it back into the interstellar night, and for most of the world, it was forgotten. But in truth, 3i/Atlas was never just about itself. It was about what it represents. It was a messenger, not in the mystical sense, but in the stark reminder it delivered. These objects exist, they come here, and one day, one of them may not pass us by. We live in an age where discovery is accelerating. Telescopes grow more powerful, computers more precise, surveys more ambitious. Every year, we find more asteroids, more comets, more potential threats. And yet, with each new discovery, the unsettling reality sharpens rather than fades. The more we see, the more we realize how much we still miss. If 3i/Atlas had entered just a little dimmer, If the weather over Hawaii had turned cloudy, if funding had faltered for even a few months, we might never have known it passed at all. The fact that we saw it is not proof of mastery. It is proof of luck. The inevitability of more visitors is not in doubt. Oumuamua in 2017, Borisov in 2019, Atlas in 2022. 3 in just 5 years, after centuries of seeing none. This is not because they were never there before. It is because we were blind. Now our vision improves, and with it, the realization that we are surrounded by travelers from beyond. Some will be small, faint, barely worth noting. Others may be larger, brighter, more dangerous. The dice are rolling, and one day the numbers will fall against us. Humanity likes to think of itself as enduring. We build monuments of stone and steel, we carve our names into history, we send probes into space with plaques declaring who we are. But against the backdrop of cosmic time, we are fragile and brief. Dinosaurs ruled the Earth for over 150 million years. We have been here for only a fraction of that. And already, 3 times in living memory, the sky has reminded us of our vulnerability. Tunguska, Chelyabinsk, and now the interstellar visitors that slip past us in silence. To assume that we will be spared forever is not confidence. It is denial. There are those who argue that we will be ready. That one day, we will have fleets of spacecraft, vast nets of sensors, planetary defense systems capable of intercepting any threat. Perhaps. But readiness is not simply a matter of technology. It is a matter of unity, of foresight, of prioritizing survival over division. And history does not suggest that we are skilled at those things. We quarrel over borders, over ideology, over resources, while the true threat does not care for our arguments. An interstellar comet does not pause at checkpoints. It does not recognize treaties. It comes whether we are prepared or not. The silence of space makes this worse. The void between the stars is not empty, but it is mute. Objects like 3I/Atlas do not roar their approach. They glide invisibly until the last moment, until a telescope catches a flicker, until a scientist draws a line across a star chart and realizes the truth. By the time we know, it may already be too late. This is the nature of the cosmic lottery: no announcements, no warnings, only outcomes. And yet, in that same silence, there is awe. To glimpse an interstellar visitor is to look beyond our own small neighborhood, to see evidence of the galaxy's restless exchange. Worlds bleed into one another. Star systems scatter fragments across the void. Every visitor is a reminder that we are part of something vast, something far larger than ourselves. It is both terrifying and beautiful. We are not alone in the sense that the material of other worlds touches ours. And perhaps, just perhaps, that is how life itself spreads. If the building blocks of biology travel on comets, then every interstellar visitor is not just a threat but a potential seed. Some may kill, but some may create. This is the paradox at the heart of comets. They are parents and executioners. They give life and they take it away. 3I/Atlas carried that paradox as it passed, silent and fleeting. To study it was to confront the possibility that we owe our existence to such wanderers, and that one day one may also erase us. That symmetry is haunting. The same process that may have birthed us could also end us, without malice, without intent, simply because the dice rolled that way. What, then, is the worst that can happen? Extinction is the obvious answer, but it is not the deepest one. The worst is not just that we die, but that everything we have built, everything we have dreamed, everything we have loved, is erased without trace. That the earth, once alive with voices, becomes silent again, another barren rock circling the sun. That the universe, indifferent as ever, goes on unchanged, unmarked by our passing. That is the true weight of cosmic indifference, not hostility, but forgetfulness. And yet we resist. We build telescopes. We tell stories. We send messages into the void, knowing they may never be heard. We prepare in small ways, even if imperfectly. We carry the burden of Atlas, holding up the sky with our vigilance, even though the sky does not notice. This defiance is fragile, but it is ours. To care in a universe that does not is an act of meaning, even if that meaning is only temporary. So perhaps that is the final legacy of 3i/Atlas. Not its data, though that is precious. Not its orbit, though that was calculated. Its legacy is the reminder that we are both small and aware. That we live in a dangerous cosmos and we know it. That we fear the worst, but we also marvel at the best. That we are capable of dread, but also of wonder. And perhaps that combination, fear and awe together, is what makes us human. One day, another interstellar visitor will come. Perhaps tomorrow, perhaps a century from now. It may be harmless, a faint streak of light barely noticed. Or it may be large, fast, and merciless. The worst that can happen may unfold before our eyes, or it may not. We cannot know. But until then, we live beneath the stars, fragile but alive, watching the sky as Atlas once held it, knowing it may fall, but holding it anyway. And in the quiet hours, when sleep comes and the mind drifts, perhaps that is the thought that lingers. The sky is not safe, but it is beautiful. The dice are rolling, but for now, we are still here. 3i/Atlas has passed, but its shadow remains, whispering that in the vast silence of the universe, survival is not promised, and that is what makes it precious. And so, as 3i/Atlas fades back into the silence of interstellar space, we are left with more questions than answers. It came without invitation, stayed only for a moment, and left us with a reminder of just how fragile we are beneath the stars. Objects like this do not need permission to visit. They do not wait for us to be ready. They come as they always have, quietly, indifferently, and without warning. We can measure their paths, record their light, and whisper our fears about what could happen if chance tilted differently. But in the end, the truth remains. We are passengers on a small world, drifting through a dangerous galaxy, surviving only because the dice have not yet fallen against us. The worst that can happen is always out there, waiting. But so too is the wonder, the awe of knowing that we can look up, see, and understand, even if only for a fleeting moment. That is our gift. That is our defiance. And that is why, as the stars will overhead, we keep watching the sky.